Alright, hello everyone. Today I'm going to be demoing my project that I've been working on for at least the last week. It's a machine learning project that's able to predict what number you drew from 0 to 9 in this little canvas here using a model I trained myself. And before I demo it for you, I want to show you the idea behind the project and how did I even get here. It all started on Kaggle, and I was looking for machine learning competitions to do, or something fun, and I saw this digit recognizer. And the data set that I'm given is essentially 42,000 hand-drawn images of numbers 0 through 9, but they aren't given to us as images. They're given to us as 28 by 28 pixels, and 28 times 28 is 784. So it's a row of 784 columns, and each column represents the position of that pixel, and the data inside that cell represents how light or dark it is. And if you put it all together, it would draw a number. So it's a pretty large data set of a lot of numbers, and then hopefully I can show it to you really quickly here. Alright, so this is a quick example of what the data set looks like. As you can see, it's a lot of columns of just a lot of numbers, not very decipherable by humans. So that's the idea of how it came up to be. I originally trained it, and the model was pretty accurate, but it begs the question, was I able to use this model to detect real hand-drawn images, not just the dataset that was given to me? And that's how the project essentially started. So let's get here, and I want to talk about the project and demo it for you. So the stack I use is Python for the backend, FastAI and PyTorch for training the model, and React and Vite for the front end. And let's test it out here. So let's draw a 1 and see if it can get it. Alright, got a 1 pretty good. Let's try 7. Oh, got a 7. Let's try a 6. Okay, and let's finally do a 3. Ooh, it kind of clipped a little bit here. Hopefully it should get it. Oh, 3, perfect. Alright, and now let's hop into the code. Alright, so here we are at the Jupyter notebook where the model was trained. Let's go over the first one, then I'll get into detail on the second one, which is the one I actually used. The first one was trained on a random forest, which is a pretty classic machine learning algorithm, and it's really good at tabular data, so like spreadsheets, which is why I used it. But the only issue is, which I learned afterwards, is it looks at each pixel independently, and it doesn't account for spatial patterns or how this pixel looks relative to another pixel or the whole entire picture if there's thousands of pixels. It just looks at one piece independently. And that was pretty accurate for training the test data, which is the highly refined scans that I had, and it had a 96% accuracy. But soon as I used it on hand-drawn images that were a bit sloppy, it quickly fell to maybe 30 or 20%, which was not usable, and I could not demo that. So I had to start from the drawing board, and I eventually landed on using a CNN, a convolutional neural network, which actually is able to process image data a lot better. It's built on ResNet, which is a model created by Microsoft back in 2015, and it's very, very good at analyzing image data. And one of the biggest hurdles that I had was figuring out to use data augmentation, because the images that this is trained on are highly refined and they're all in the center of the screen and perfectly drawn. But let's say someone drew the circle, but it was tilted a little bit. I have to make sure the model can determine what a circle looks like when it's tilted, so I use data augmentation. And I'll pop a couple pictures on the screen of what that would look like, and I made sure to set do flip to false, because let's say it flipped a 6 and it flipped it around and it looked like a 9. You don't want that to happen, but we did want to like change the proportions, maybe tilt it, things of this nature. And when I trained it, I got up to a 98% accuracy, which is very, very good. And here's just a little example of what the data looks like when I'm feeding it to the model. Alright, next we're going to get into the front end and back end code. Alright, so here we are at the front end. It's all pretty much made in one React element called the canvas. And I use React sketch canvas for the sketch that you see where I'm able to draw. And the bulk of the program is actually in this function here called convert to 28 by 28 grayscale, because we want the image to be in the same format that the data was trained on, our model was trained on. So here's how it works. First, what we do is create a new canvas with the exact pixel measurements of our data set, so 28 by 28. Here we get the canvas's context, so basically a 2D array of all the pixels. And next we want to draw our image on the 28 by 28 pixel canvas, starting at position 0, 0, so the top left corner. Next we get the image data, and we're going to pass that to store that in a variable called data, and that's all of our image data. But the image data actually has RGB, so it has the full color spectrum. We want to convert to grayscale, so what we're going to do is grab the red, blue, and green properties from each pixel, and we're going to add them together and divide them by 3 to get one value, which would be the grayscale value of how bright or dark that pixel is. And next we just return the grayscaled image. And once we click the submit button, we're just going to call that function on our image that we got from the front end and send it to our back end for processing through the model. And that's pretty much how the front end works, and let's get into the back end. Alright, so here we are at the backend code. It's a simple Python backend, and I use Flask for the web hosting. And it has one simple route, which is called the predict route, and it's a post request that receives the image data that we just saw on the front end. And what it does is it gets the pixel value, stores in the pixel value. I have this fail-safe so it doesn't crash the app. So if there is no pixel values or the length is not 784, which is the correct format, we're going to send an invalid error back. Next, we convert our pixel values into a NumPy array, which is the language that our model speaks essentially, because it doesn't look at regular arrays. And here we have to convert it back to a 3-channel array. As you remember before, we had to convert it into grayscale, but the model we're training on expects 3 channels. So what we do here is essentially copy over our one grayscale channel, and we're going to plug that into the red, blue, and green, so it's fitting the format but not giving it a full color spectrum. So it's making a 3-channel model accept a grayscale image. Next, we send that 3-channel array, and we're going to grab the prediction and send it back, and that's pretty much how the app works. And it was pretty fun to build, and I hope you guys enjoyed the video. Alright, and if you guys enjoyed the video, drop a like. If you have any recommendations of things I could have done differently, things I could do better, or any video ideas in the future, just drop them down below. Alright, hope you guys enjoyed.